When I was 10 years old, I was obsessed with numbers. I counted everything and anything around me. I became a quantifying machine, a human calculator. I would go to a birthday party and counted how many children were at that party. On the next birthday party, I would count how many kids were there. And I was able to compare two numbers. I was curious if a higher number of children makes the birthday party better. I wanted to know, quantify, model, predict what makes a birthday party to be good. I also did a very interesting thing. I knew and remember the birthdays of everyone. The first scientific hypothesis in my life, kids who are born on the same day like me are similar to me. We would have many things to talk about, we would connect, and we would be friends forever. Early data proved my hypothesis to be wrong. And I learned one type of data alone does not enable you to know how people make connections and how can they be friends. I observe where you sit affects directly who you become friends with. And I further notice groups of people sitting together develop a relationship and a connection that make them become friends. I decided next year I will choose this kid, I will stick with him. For the entire year, we will make connections and we will be friends. I made a mistake. The kid and me did not have the same birthday. At the end of the year, we got along okay, but we did not become friends. I have ignored the data and the ability of data to inform decisions. Numbers are the language of science and engineering. They allow you to understand your environment. They enable you to touch information. I love numbers, and like in the birthday party tonight, I counted each and every one of you using one sensor that I brought here. A sensor is a machine, is a tool, is an instrument that collects information that is important to you. A sensor has a sensorial component that is connected to electronic circuit. The resistance of that component when for example, temperature goes up and down affects the voltage. The voltage gets digitally printed in a record with quantity and unit. And that information enables you to make decisions. I really like to build sensors to measure very important things for me. Many of us have a garage door in our house. Some of us have a garage door with a mind of their own. My neighbor Rick texts me, the garage door is open again in the middle of the day. When Rick is traveling around the world, having fun, I don't know what's the status of my garage door. So I decided to build a sonar sensor. I put the sonar sensor inside my garage. The sonar bounces back and forth to the door from the inside at 40 inches. If I read my sensor and I have 40 inches, the garage door is closed. If the distance is higher than 40 inches, the garage door is open and I have to go back and close it. I also like to build sensors for people to collect information that is important for them. I worked as a railroad bridge engineer for 10.5 years. I participated on the construction of more than 30 railroad bridges across 7 states in the United States of America. The owner of the railroad asked me, I am sure you can build a sensor to measure the transverse displacement of the railroad bridge when the train is crossing. If the railroad bridge moves 1/4 of an inch, that's the thickness of your iPhone, you are okay. If you flip your smartphone, the width is 2 inches, 2.5, you are in serious problem. You need to fix that bridge. If you turn it horizontally, about 5 inches, you have an earthquake under your train, you better not be there. Information from sensors about the infrastructure to inform decisions. A smart management of infrastructure. In 2015, I joined the University of New Mexico, and I wanted to create a laboratory for the smart management of infrastructure. So I did, and I named it a Smart Management of Infrastructure Laboratory. SmileLab. SmileLab is people we have from high school to professors from all different departments and units sharing different training and knowledge to fabricate sensors, robots, algorithms that inform decisions. SmileLab is a traveling ticket. The students go from Alcatraz Island in San Francisco, put the sensor, or Puerto Rico, from Half Moon Bay in California to the state of Tennessee. SmileLab is mostly an education engine. We believe we can train anyone to fabricate their sensors to measure what they want. So we invented the solution: low-cost, efficient, wireless, intelligent sensors. We named them low-cost, efficient, wireless, intelligent sensors, or LUIS. We trained 54 children from Comanche Elementary School of 8 years old or younger to build LUIS sensors in less than 30 minutes. With colleagues from California and Florida and the teachers, we took the Rail Runner train from Albuquerque to Santa Fe, and those kids were measuring the lateral vibration of the train when crossing bridges. Now, in my classes at the University of New Mexico, every student has to build a LUIS sensor and solve the homework in less than 30 minutes. I take the graduate students on the Rail Runner train from Albuquerque to Santa Fe, and they had to make an exam on the train. The graduate students love me more and more, I think. We have a high schooler from Menal Academy here in Albuquerque, New Mexico, Selene Diaz. Selene wanted to use the sensor for something else. She decided that the sensor on the floor could quantify the quality of her ballet dancing. She had 6 moves, and she worked on the data to rank the improvement of certain movements. Selene Diaz wrote a paper, sent it to the conference, and it was accepted, and she presented at the MIT in the Engineering Mechanics Institute. And according to the host institution, the American Society of Civil Engineers, Selene was the first high school ever to present at this conference from Albuquerque, New Mexico. We have LUIS at the Sandia Peak Tramway, 10,000 feet. I went there last night.
We are measuring the Rio Grande water going up and down. We have Lewis in Chama. We have Lewis in Oquewingue Pueblo. We compare the effect of fire with the rain and the flooding after the fire. We have Lewis at the Tinkertown Museum on the East Sandia Mountains to measure people at the museum and rain on that side of the mountain. And we have Lewis at the garage of my house. I asked one little group of children, why do you like building Lewis? This 8-year-old girl said, I like building sensors because connecting cables is like making friends. I thought I was 10 years old again. Building sensors, collecting information, exchanging ideas enables us to meet new people and to learn from each other. We can also change our environment with information that we can all look at. Build sensors, make connections, connect cables, make friends.